Now let's have a look at when we've got a complex number and we want to find the locus of that complex number with an argument. So this time we've got the situation firstly up of the argument of z is pi on 3. So what we're looking at is that any line that's going to be, any point that's going to have an argument of pi on 3. So if we look at that, the red line here is going to be the complex numbers with an argument of pi on 3. Now, notice what that's going to be. It's the angle there is pi on 3. It emanates from the origin and then goes out and doesn't stop. We call that a ray. We know that's a ray. It's a part of a line. Starts at a point and then goes on forever. Now, what's important, and might not be able to pick it up here, that we're not including the origin here. Because the argument of a locus argument's not defined at the origin, like pi on 3 is not the argument of the origin. So if that's the case, we don't include. So we put an open circle there. Okay, just important to know. You might not get picked up in the exam about it. Depends how pedantic they are. But technically, we shouldn't include that point because that shouldn't be part of that line. It's any other point that's at pi on 3. It's not on this side because that would have a different argument. That would be an argument of minus 5 pi on 3. So argument there, if we had an argument of z is minus 5 pi on 3, the line would be going in that direction. So we've got to look at, well, what's the argument of any point that is got an argument point of pi on 3. So looking at these ones, we've got argument of z plus 2i is pi on 3. So again, this one here, it's really just a case of, well, where's it starting? Again, open circle with an argument. Starts at 2i, so starts at minus 2i because it's z plus 2i, and it's got an argument of pi on 3 there, so it's at that angle there. Argument of z minus 1, so it starts at 0, 1, and has an argument of minus 3 pi on 4, which would be going in that direction. So this is what we're talking about when we're looking at the arguments of the point. So we're going to start from a particular point, whatever we've got there, and then the argument goes off in that direction, and it's going to be a ray with an open circle there. So if we've got an inequalities type situation where the argument of z is between 0 and, well, it's greater than 0 but less than pi on 3. So anything that's greater than 0 is in the green here. So the darker green, it's a little bit hard to see. It's not coming up very nicely. Remembering that we have looking at a situation where argument of greater than 0, it's going to be greater than there, and argument less than pi on 3. Now notice it's been included all here, but we're looking at, and I've got green here too, which isn't great, so let's get a different color. So I'm trying to get a different color, but it's not coming up. So we're looking at this area here, if you can pick it up, that area in between. So it's greater than 0 but less than pi on 3. Now ignoring this part, these parts here, because greater than 0 would be anything around there, and then less than or equal pi on 3 is that area there. A little bit easier to see with the next one here, where we've got argument of z's between 2 pi on 3 and 4 pi on 3. So it's greater than 2 pi on 3 but less than 4 pi on 3, which is the same as minus 2 pi on 3. It's minus 2 pi on 3 around there, or 4 pi on 3 around there. So the argument must be between those. Notice open circle at the origin because it's not, argument of z is not including the origin, and these lines are dotted this time, so it's not including it there. So this is a little, again, different situation. We've got the argument of one complex number divided by another is equal to some number. Now what we want to do is go back to our idea of when we take the when we do the division of two complex numbers, the argument of each is the subtraction there. So what we're doing is subtracting the argument of one complex number from the other. So dividing the complex number and taking the argument is the same as doing the subtraction of the arguments. What it's saying here is that the difference in the arguments is equal to pi on 2. Now, the trick with this one is to consider those two complex numbers. We've got z minus 1 is at B there, and z plus 1 is at A. So we're saying that the argument of z minus 1 would be, and subtract the argument of z plus 1 is 90 degrees. So if we let the argument of z minus 1 be theta, so that's theta, that's the argument of z minus 1. This is the argument of z plus 1. Now, and we rearrange it, we're saying that theta minus phi is equal to pi on 2. So what we're looking at this situation is that by the exterior angle of a triangle, if we look at it, the idea that theta would be equal to pi on 2 plus phi, and that describes this triangle here, where the exterior angle of the triangle is equal to the sum of the opposite interior angles. So there's our two angles there that must add up to give us that one. So if you can see that here, that theta must be equal to pi on 2 plus phi, or theta minus phi is equal to pi on 2, which describes one argument minus the other equal to pi on 2. So when you see that, and then you go, well, okay, that's forming a right angle there. What must it be? Well, that starts to give us a situation where AB can be a diameter of a circle, because that forms an angle in a circle. If you remember our circle geometry rules, that's the angle in a semicircle, which means we get a semicircle, because pi on 2 can be anywhere. Like pi on 2 can be moving here, moving anywhere along there, except at these points here, because that's not going to work, because it's going to give us 0 there or pi there. So, but any other time, it's going to be an angle between them being pi on 2. So that's where we're getting this idea from. So there's the trick with this one. Consider the difference of the two angles and the triangle that would create there. If we have a look at the next one, we get the same idea. So this time, the argument of z minus 2, well, there's z minus 2 there. So we get this argument minus this argument is equal to the angle between them there, because these two add up to give us that one. So this one minus that one gives us that. So that would be pi on 3. Now it's a little bit hard to see, but that's going to give us an arc of a circle. And it's not going to be a diameter, it's going to be a bit big, because it's going to form a 60-degree angle in between it. So that's what we're seeing when we do that type of this type of question, this type of argument locus question. So looking at the argument between the two, so draw them up and get the line between it, and you're going to be able to find that it's going to be an arc of a circle. If it's pi on 2, it's going to be a semicircle. If it's pi on 3, it's going to be the top arc of a circle. If it was say 2 pi on 3, it's going to actually form the smaller arc of a circle, because it's going to be a wider angle there. If that was around the other way as well, it'd start to swap around. So in questions you'll do a lot more. So this is what you're looking to do with these types of questions.